Hello everyone, in this video we are going to see about how the queue is represented either using the array as well as the linked list. We know that queue is a first in first out data structure, is a linear data structure. Here queue we have rear and the front points, and it is the first in first out data structure. We have the rear and the front points to add and delete the elements. So here when you are adding the element in the rear, that is called as an enqueuing, adding something into the queue, entering into the queue, that is the enqueue operation. And for deleting from the queue, it is called as a dequeue operation. It happens in the front. Okay, so insertion and deletion happens on different ends. In the stack, it is both the insertion and deletion takes place only in the top position, which is the top of the stack. Here it has two ends, rear and the front, rear for entering and front for deleting the values from the queue. Let us see how the representation is done both in the arrays as well as the linked list. Before that, we will see what is the application of queues. Queues are used in lot of applications. A few of them are: queue is used to implement many algorithms like breadth first search, etc. Actually, this is one method of exploring the tree structure. For this, we are using the queue as the data structure. And the next one is, it can also be used by an operating system when it has to schedule the jobs with the equal priority. Inside the operating system, the jobs are scheduled. For that scheduling, the queue helps. We have job queue, device queue, and many queues are there. Those queues will help to schedule the work of the operating system. And then the third application is the customers calling a call center are kept in queues when they wait for someone to pick up the calls. So when you are calling any customer care center, we are asked to wait in queue. That means the queues are processed in a first in first out person in a way, and the person who came first in the queue, they will be processed first, they will be discussed first. So that these are three applications where we can see the application of queue in general. Let us see how the queue is represented using the array. We know that array is a consecutive memory location, and here as we know that queue has two ends, head and the tail. So here head is the starting, okay, and the tail is the end of the queue. So suppose we are suppose we are making the queue and we are asked to join the queue. Just we join from the rear. So the people who join first will go to the front. So that is the head. This is the front and this is the rear, also called head and the tail. So now first entered is 2 and it is in the first of the queue, and next entered followed by 3 and 4 and 5, and now after 5 there is no entry is there. Now this is the tail. If at all some element has to be added, that will happen only in the tail portion. So now this picture shows about, suppose you are asked to add 10 in the queue. So how to add? The tail pointer is noted. So where the tail pointer is pointing, that is the position we can add the element. Now 10 is added to the tail position. Now tail becomes the next position. Tail is equal to tail plus 1. This is how the queue is represented using the array. This is the picture of an empty queue. What does the empty queue says? That there is nothing in the queue. That means both the tail and the head are same. Once you add element in this position, the tail will be incremented. When you keep on adding the elements in the queue, the tail incremented and come to the last of the queue. So this is the diagram of an empty queue. Next is the overflow in a queue. Actually, what is the overflow is, we keep on adding the values from the front to the tail. We keep on adding the values. Now there are some cases where when at the end of the queue, if you want to add some value, it naturally goes to the front of the queue. It works like a circular queue. So after that we have to add the consecutive elements as long as the spaces are there. Now when we say that tail is next to head, that means head, actually in general head first and the tail last, but in the circular fashion, when the tail becomes to the end, the queue starts from the front of the queue. In that case, when you keep on adding the elements, so now suppose if you are adding the element in this position, there is no vacancy to no empty position to add the value. Suppose if we want to add more element, now the pointer points to the start of the queue, which is the head. So now this becomes the tail now. Okay, so we are adding some value to the tail, then tail becomes tail plus 1. And now when the tail is before the head, that position is called as an queue overflow. Normally tail will be followed by the head. Now head is followed by the tail. This condition is called as an queue overflow. So that's all the queue representation using the array. Now let us see how it is done using the linked list. We know that linked list consists of the data and the address node. Okay, so now in the linked list, the header is the first front of the queue and the header pointer points to the successive element of the queue. Likewise, we know that the concept of linked list, the address points to the next element of the array or the list. So successively this pointer 5 points to the position of 9 and 9 points to the position of 4 and 4 points to the position of 10 and now 10 points to the position of null. So if nothing is pointed, that is the tail pointer. Initially this becomes the head pointer. So this is how the queue is represented using the linked list concept. Now let us see what is an empty queue. In the case of linked list, again the same, the head and the tail are same for empty queue, but here the null pointer is also the same in the head. So the head contains also the starting and the null pointer, which is the empty queue. So that's all the simple concept of how the queue is represented using the array and the linked list, and it's a simple representation. It's easy to follow, and thanks for watching.